Hello everyone, I'm Pranjal Chatterjee and welcome to my first video in the series High School Competition Math Explained. In this video, I'll be talking about frequently used concepts and equations and explaining how they can be used in competition problems. Let's start with the problem that demonstrates the importance of factorization. If a is not equal to b, a cubed minus b cubed equals 19x cubed, and a minus b equals x, find a in terms of x. This problem looks like it may need a lot of substitution, but in fact, some quick factorization can solve this problem pretty quickly. Before we can continue with the problem, we need to know some important factorizations. The first one is the difference of squares formula. The second one is the perfect square formula. The third one is the difference of cubes formula, and this will probably be helpful in our situation. The final one is the general formula for differences. See if from this formula you can find the formula for a to the 2n plus 1 plus b to the 2n plus 1. Does this work for even numbers? Now that we know many factorizations, let's try to apply them to a problem. Reduce this fraction, a squared plus b squared minus c squared plus 2ab over a squared plus c squared minus b squared plus 2ac. Before I continue with the solution, try to pause the video and solve the problem yourself. Two factorizations that pop out immediately are the difference of squares factorizations, which are b squared minus c squared and c squared minus b squared. However, if we factorize these, we have two other terms that make no sense. So let's try to look for other factorizations. Another one that pops out is the a squared plus b squared plus 2ab and a squared plus c squared and 2ac, which are both the perfect square factorizations. So after factorizing these, we get a plus b squared minus c squared over a plus c squared minus b squared. This is just the difference of squares factorization, so we can factorize it once more. We get a plus b plus c times a plus b minus c over a plus c minus b times a plus c plus b. These two factors cancel out, and then we are left with our answer, which is a plus b minus c over a plus c minus b. Let's get back to the first problem now. If a is not equal to b and a cubed minus b cubed equals 19x cubed and a minus b equals x, find a in terms of x. First of all, we can just simplify this a cubed minus b cubed into a minus b times a squared plus ab plus b squared equals 19x cubed. We see a minus b, and we know that a minus b equals x, so we can cancel this out with x. This x also cancels out with the x cubed, and we get x squared. Once we see this expression, we may not know what to do next. However, it resembles another expression that we've seen before, the perfect square factorization, which is a squared minus 2ab plus b squared equals a minus b squared. And since we know what a minus b is, maybe we can convert this expression into that expression. So let's try. Let's get a squared minus 2ab plus b squared. What do we have to add to negative 2ab to get ab? It's just 3ab. And this just cancels out to x squared. And we have 19x squared on this side. So the x squared comes over to the side, becoming 18x squared, and we get ab equals 6x squared. And paired with this equation, a minus b equals x, we can solve and get the answer as a equal to negative 2x or 3x. The second topic is with systems with slick forms. For example, these two questions look pretty complicated with 3 and 4 variables. However, they can be solved pretty quickly and easily. Try to pause the video and solve these equations in whichever way you like. The first problem asks to solve this system of equations. Now, nothing pops out immediately, but with some observation, we see that there are 3 w's, 3 x's, 3 y's, and 3 z's. So let's add them up. We get 3 times w plus x plus y plus c equals 57. And dividing off the 3, we get 19. So what can we do with the sum of the variables? And how do we find the actual values of the variables? Well, what happens if we subtract off each of the equations from the sum? We get the actual values of the variables. So we find that z equals 9, y equals 11, x equals -4, and w equals 3. Let's go on to the next system of equations. There's something similar going on here with 2 x's, 2 y's, and 2 z's. So let's multiply it together. We get x squared, y squared, z squared equals 35 squared. We can take off the squares, but we have to remember that there are 2 solutions, so it's plus or minus 35. Similarly to the previous system, we can divide off the previous equations from 35 plus or minus 35. So we get z is equal to 7 root 5 over 5, plus or minus 7 root 5 over 5. Y is equal to plus or minus root 35. And x is equal to 5 root 7 over 7, plus or minus. So the final solution, as they told us to put it, is plus or minus 5 root 7 over 7, plus or minus root 35, and plus or minus 7 root 5 over 5. Here is the final topic, relations to roots. Consider the system of equations, and then this big system. What are the values of a1 plus a2 plus a3 plus a4 and 64a1 plus 27a2 plus a3 plus a4? These equations look really complicated, and the answer even more so. We may need more information. This is where the fundamental theorem of algebra comes in. The fundamental theorem of algebra states that all non-constant polynomials of degree n have exactly n roots, which can be complex or real. Also, any polynomials with more than n roots of degree n are 0 everywhere. Now that we know this theorem, we can come back to the problem. Try to pause the video and see if you can find a similarity in these equations. If you found that these equations have this form, good job! If we can prove that all solutions have this form, we may be able to solve this problem. So, let's start. We can move all of this to this side, and we get a polynomial that equals 0 for 4 roots. But that's not possible since this has degree 3. So it must be 0 everywhere. We can get a1 plus a2 plus a3 plus a4 from the leading coefficient, and that is equal to a, so that is one solution. We can get 64a1 plus 27a2 plus a3 plus a4 by plugging in -4 for x. We get negative of this whole sum, and that is equal to -9 cubed, or -729. So the sum is just equal to 729, and we have our answer. Thank you for watching. Make sure to like and subscribe, and press the bell icon for more updates.